CAM manufacturing processes. CNC milling design. Milling is the manufacturing process of using rotary cutters to remove material from a workpiece by advancing or feeding in a direction at an angle with the axis of the tool. It covers a wide variety of different operations and machines on scales from small individual parts to large heavy-duty gang milling operations. It is one of the most commonly used processes in industry and machine shops today for machining parts to precise sizes and shapes. CNC is the advent to milling, which is the automation of machining tools that are operated by precisely programmed commands encoded onto a storage medium, computer command module, as opposed to controlled manually by hand wheels or levers or mechanically operated by cams alone. This mode gives a broad range of industrial processes that alter the surface of a manufactured item to achieve certain properties that may be improved appearance, adhesion or wettability, solderability, corrosion resistance, tarnish resistance, chemical resistance, wear resistance, hardness, modifying electrical conductivity, removing burrs and other surface flaws, controlling the surface friction, or restoring, salvaging, or repairing an item. Here we have a mold cavity imported from SolidWorks. In a manufacturing assembly setup, we will be retrieving a machine with a table included, so we are able to delete this table and continue on to manufacturing mode by proceeding to the Applications tab and then into Manufacturing mode. So our material is already set, and the first thing we would do is set up the position for our world coordinate system, which I have already done, but you are able to by going to Menu, Format, and changing the WCS dynamically to the corner and the top level of the part, where we will also place our MCS mill accordingly with it. So all of our G-code will be the smallest values to print possible. Now in our Programs Orders view, I have previously created program groups within the unused NC program, where I would right-click and insert a program group. You're able to give it a type and give it a location. I've named mine Roughing, Semi-Finishing, and Finishing within the Millings program group. Also within the Machines Tool Navigator, I have created a carrier by inserting a tool operation as a carrier and inserting 8 pockets to correlate with the machine's interchangeable tools. Within these pockets, I have highlighted and inserted tools for a 25mm end mill, a 8mm end mill, a 6mm bowl mill, and a 2mm ball mill by retrieving the tools from the library within the Millings classification. So we are now ready to start creating our operations for our roughing, semi-finishing, and finishing of this workpiece. And we will do this within the Machine Tools Navigator by selecting the 25mm end mill, right-clicking and inserting an operation. The first will be a mill contour plunge milling operation. Within the roughing program we've created, selecting the workpiece as the geometry and the method as a rough. Now within the plunge milling operation, there is an automatic retract, so there is no non-movements to define. So we can leave this operation with its default settings and proceed to the 8mm end mill. And create a fixed contour operation, which will create a nice semi-finish across these contours of this workpiece. With a semi-finish method within the program group, semi-finishing. We will create the drive method as a area milling method and leave the non-steep and steep cutting drive settings as default. And we will double check our non-cutting moves to assure that the transfer in rapid has a part safe clearance of 3mm, which it does, and hit OK. And accept the operation. Now within the 6mm bowl mill, we will create a Z-level profile operation. Within the finishing program group with a finish method, we will create the common depth per cut to 1mm, define the cut area, accept the cut area, proceed to the cutting parameters, and create the cut direction as a mixed cutting parameter, and set the connection to use a level to level cut distance direct on the part, which will cut between the levels, which will include non-steep geometry of the workpiece. and hit OK. Now we will set the non-cutting moves to assure that the transfer and rapid has a between regions from the lowest safest Z region of a 3mm clearance, and accept the operation. Now we can create our last finishing cut as another Z-level profile with a smaller tool to adhere to the small radiuses correlated within this cavity with a finishing program group and method. And we will make the merge distance, minimum cut length, and maximum depth per cut 0.2 millimeters. Now we will enter into our cutting parameters and select our strategy to be a mixed cut and create the connection method to be direct on the part. But for this method, we will not include cut between levels since we have already finished it with a previously bigger tool bit, and operation has already produced the final cut on the planar levels of the workpiece. We will proceed to the non-cutting moves and ensure our transfer and rapid is using a low safest Z region for clearance of 3mm. Hit OK and specify the cut area. Accept the cut area and create the operation. Now when we proceed to the program orders group, we can see that our operations are all organized within our program groups for roughing, semi-finishing, and finishing, and we are ready to generate this setup. Accept the paths, and we are ready to verify and analyze any leftover material in a 3D dynamic tool path visualization. We will analyze the leftover material by showing thickness by color and selecting any point on the part to see the distance of leftover material, which we are on average getting 20 thousandths of a millimeter, which is more than acceptable for any CNC machine in this generation. Now from here we are able to post-process the operations and setup and import our G-code into a CNC machine to manufacture this piece, but for further analysis we will import a 3-axis mills environment and run a machine simulation to verify if any of the tool paths have any collisions. We will do so by proceeding to the Machine Tools Operation Navigators, highlighting the generic machine, right-clicking, editing it. We will retrieve the machine from library as a mill classification, and we are given a large array of CNC machines we are able to import into this setup. We will choose a 3-axis mill vertical Fanuc mill and select all of our components for the part mounting. And we will position the machine by constraints. Once we accept the constraints, we are prompted with an information box that uploads all of our Pocket's customized tool magazine, and we are able to regenerate this tool path and simulate the machine. Now we can hide our parallels and vice bolt set for clearer visualization and simulate our machine. Process with a show 3D material removal at a 50% speed. And as the operations change between the tools, the machine will change the tools accordingly. And if any tool collisions or limitations are conflicted within this manufacturing process, we will be prompted with an error dialog box, and we are able to proceed back into the manufacturing mode and edit the tool's parameter or operation to adhere to those issues. And that concludes our 3-axis computer-aided manufacturing tutorial.